The Mesophotic zone starts about 160 feet below the ocean's surface, as less and less sunlight is able to penetrate the water. Mesophotic means middle light and is sometimes called the twilight zone. Benthic refers to the seafloor, so Mesophotic benthic habitats are those along the seafloor from about 160 to 980 feet down. As you travel beyond the Mesophotic benthic zone, you'll eventually reach a point along the seafloor where there's no sunlight at all. Down here, the water also gets colder, and there's much higher pressure. This is the deep benthic zone. Despite the low light, cold temperatures, and high pressure environment, there are incredible ecosystems that call the seafloor at these depths home. Colorful corals and sponges are the foundation of these ecosystems, providing habitat for the many fish and invertebrates you see here. These deep sea ecosystems are found all over the world, including in the Gulf of Mexico. Unfortunately, the Deepwater Horizon oil spill dealt a heavy blow to Gulf communities on land and at sea. 11 people lost their lives, and natural resources were severely impacted. Restoration is particularly challenging for the deep coral habitats that were injured because of their distance from shore, depth from the surface, and just how much we still have to learn about them. As a result, 4 restoration projects are currently underway to help us better understand and restore these seafloor ecosystems from 160 feet to thousands of feet below the surface. These 4 projects are using a combination of new and proven techniques. The Mapping, Ground Truthing, and Predictive Habitat Modeling project is mapping new areas and improving existing maps of the seafloor in the Gulf of Mexico, so we know where these coral habitats are found. The Habitat Assessment and Evaluation project helps us learn more about the species that live on the seafloor and how they may be connected across the Gulf of Mexico. The Coral Propagation Project involves collecting samples and testing different methods to help corals grow and reproduce in the wild and in labs in order to help replace the corals impacted by the oil spill. The Active Management and Protection Project is working to reduce the threats that these ecosystems face and connect this restoration work to the public. All 4 Mesophotic and Deep Benthic Communities restoration projects are currently in their 3rd years of implementation. Every year, a multidisciplinary team of partners spends more than 100 days at sea to complete crucial field work and conduct restoration activities. In one recent mission, the project teams spent 20 days at sea with the U.S. Navy Experimental Dive Unit. The mission utilized Navy saturation divers who stay in a living chamber that is slowly pressurized to their deepest diving depth so their bodies can adjust safely to the pressure of diving to depths up to 1,000 feet. The divers move from the living chamber to a diving bell and then to the seafloor. This allows them to return to the surface without extra time needed to decompress after each dive. The ship also deployed several types of technology, such as remotely operated vehicles and autonomous benthic landers, to conduct habitat surveys, collect biological and sediment samples, and to fill knowledge gaps and support coral propagation. The team on board also coordinated the removal of invasive lionfish, installation of mooring buoys, and the removal of marine debris of all sizes. The high-tech tools, experienced divers, and experts from various fields work together to accomplish goals from all 4 restoration projects. This was one of the first significant NOAA and Navy collaborations in the Gulf of Mexico, the deepest dive by humans for a NOAA Science and Natural Resource Restoration mission, and one of only a handful of times saturation diving has been used for a NOAA mission. The Mesophotic and Deep Benthic Communities restoration work is made possible by the Deepwater Horizon Open Ocean Trustees. Work is led by NOAA and the Department of the Interior, including the U.S. Geological Survey and Bureau of Ocean Energy Management, plus many partners, including a large number of academic institutions and non-governmental organizations.